In the next few videos, we're going to be talking about what variation is, and going through some examples and things like that. But before we actually get started on examples, I'd kind of like to look at what variation truly means. And you already have some understanding about this, you just may not know that you do. So let's look at a line first of all. I have this line drawn out here, and this is actually the line y equals 2x. Now, if you'll remember from your graphing earlier, then the line y equals 2x has a y-intercept or a b value there at 0, and then it has a slope of 2, which means that you would rise 2 and run 1 to get to another point on the line. Well, that slope is something extremely important. It really does keep all the points on this line in proportion to each other. For instance, we could find another point very easily by going up 2 and over 1, up 2 and over 1, up 2 and over 1. Each one of these points has that same relationship. That's how they are, related to each other. That is very much what variation problems do. They all have in common something that we call a proportionality constant. And in the problems that we're going to be doing, our proportionality constant we're going to call K. And it works very, very much like slope does in just a regular line. It keeps all of those points related to each other in a specific proportion. Now, even if we were to look at another line, like say this one went up too high. This is the line y equals negative 2x. And again, if we were to have this in perfect slope-intercept form, then we would have a y-intercept or a b value at 0. And then the slope here of negative 2 tells us that to get to another point, we would go down 2 and over 1. And again, we would continue to go down 2 and over 1, down 2 and over 1. And we could find many, many, many points on this line, because that negative 2 is sort of that relationship that it keeps all of those points related to each other by that rule, sort of, taking negative 2 times the x value to get the y value. This is exactly the idea of a proportionality constant. So as we're going through some of the example problems, I'd like for you to think about that, to keep that in mind, and hopefully it'll make this a whole lot better of an experience.